Today we have to do counting, and this is necessary in general, but in particular it's necessary for the binomial distribution. So that's what we're going to get to. And the binomial distribution is just what it says it is. Two names. It's either 1 or 0. Up or down, on or off. So there's two things that can happen, and there's a probability of one of them occurring. And 1 minus that is the probability of the other. So we need counting to find how many ways something can happen. How many letters and numbers are on a typical license plate, Virginia license plate? If you don't have a vanity plate, what have you got? 7 characters. What's the arrangement? 3 letters and 4 numbers. Okay, how many ways can you get 0 to 9 with repeats in any order on a license plate? We got 4 places. How many can go in the first place? 0 to 9. We can have 10. How many in the next place? Repeats are allowed. Any number can go in there. Get another 10. How many so far? We got 10 times 10. Next place. 10. So that's 1, 2, 3, 10,000 different combinations of numbers to go on a license plate. There's more cars than that in Virginia. So they've got letters. There's 3 letters, all caps. How many letters can we put in the first place? How many letters are there in the English alphabet anyway? So we've got 26. First place, 26. Second place, 26. This is 26 to the third. This is 10 to the fourth. In your calculator, in Excel, something, do 26 to the third. How many are there? 17,576. We still haven't got all the plates in Virginia. There's approximately 9 million people in Virginia. At least half of them have a car. Some of them have 2 cars. So this is 17,576 times 10,000. We add 1, 2, 3, 4 zeros to that. So we've got 1, 7, 5, 7, 6, 1, 2, 3, 4. That's 1, 1, 2, 3, 1, 2, 3. 175,760,000, and there's 9 million cars. So we got enough. How about YouTube videos? What's on a YouTube video? There's a YouTube link. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They have uppercase and lowercase letters, 0 through 9 for digits, and they also have an underscore and a hyphen. Right, so that's 52 plus 10 plus 2 more. So we've got 64, and we have 11 places to put them. So these others, this was 26 to the third, that was 10 to the fourth. This is 64 to the 11th. 11th power. When you put it in Excel, This is 64, and you put in a caret. It's above the 6 to the 11th power. And what didn't I put in? The equal sign. This is 7.3787 at least times 10 to the 19th. That's a 7 basically with 19 zeros behind it. There are an estimated 400 million stars in the Milky Way. So if we divided this number equals this divided by 400 million. 400, 1, 2, 3, 4, 5, 6. We still have 1.8 times 10 to the 11th addresses. Every star in the Milky Way can have 1 times 10 to the 11th videos and still have addresses left over. How about A, B, and C? 3 letters. How many ways can we do A, B, and C? A, B, C, without regard to order. Any one of them can go in the first place. Any one of them can go in the second place. And any one of them can go in the third place. So we have 3 to the third, which is 27 different combinations of values. A, B, C, A, C, C. You can list them all. What if we have A, B, and C, and we want 3 places without repeats? How many can go in the first place? We have 3. How many can go in the second place? 2. How many in the third place? How many we got left over? 1. This is equal to 6. This is called a factorial. And it's the number of ways we can put things in n positions without repeats. So that n factorial, and the symbol for a factorial is an exclamation mark. It's like n. This is a factorial, and it means n times n minus 1 times n minus 2 times on down to n minus 1 down to 1. This is on a calculator. If you look on your calculator, there is a factorial, the exclamation mark. Also in Excel, this is FACT, factorial. And if we put in 3 factorial, you get 6, which is what we had. Right? Factorials get big fast. What if I have 4 letters and I want them without repeats? That's 4 factorial. If I do that, I get 24. If I do 10 factorial, I get 3,628,800. So these get really big really fast. But this is a way to look at how many things I can do. Now, I've got n number of things, but I don't want all 10. Suppose I have 10 things and I want to take 5 of them. And order matters. When order matters, ABC is not equal to CBA. It's got the same 3 letters, but the order is different. This is permutations. And a permutation is written permutations. And this is written PNX. This is, I'm going to take X things out of N without repeats and without regard to order. So this is a factorial that's cut off. So that this is n factorial divided by n minus x factorial. So this is how many I would get if I had all n of them. This n minus x cuts off part of that. And this is a permutation. This is like you got 10 people and you invite 5 of them to dinner. Or you've got a wedding planned and there are 100 possible guests and you can only accommodate 50. So a permutation is how many ways this thing can be arranged. So that if I have this, I have n equals 10 and I want 5. I've got 10 people, but I only got 5 places at dinner. Order matters. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 10 minus 5, which is 5 factorial. So this is 5 times 4 times 3 times 2 times 1. So when I need to calculate this, all of this cancels out with the denominator. So this is 10 times 9 times 8 times 7 times 6, 90 times 56 times 6. But in Excel, this is permute, equals P-E-R-M-U-T. You got Excel going? Type it in there. Equals M-E-P-E-R-M-U-T, permute, and it has the number, this is the n, and the number chosen, which in this case is 5. So how many ways can I do that? I had 90 times 56 times 6, which you can multiply out. Which is 30,240. That's the number of ways I can take 5 objects without repeats. Order matters here. A, B, C, D, E is different than A, E, B, C, D. So if I had 6 things taken out of 10, have 10, comma, 6. I take 6 things out of 10. I have more ways to do it. So this is with order mattering. Order matters in permutations. Then I have combinations, and this is what we really want to finally get to out of all of this. And this is a combination. Combinations x, and this is n things taken x at a time without regard to order. The order doesn't matter. ABC is the same as CBA. So this is permutations with the order taken out. And sometimes in statistics and math, this is written NX with a big paren. And this is the way you'll see it in statistics books. So we want, say, 10 things taken 5 at a time. Come on. And order doesn't matter. So this is permutations with order removed. This is n factorial divided by n minus x factorial. That's permutations. And then the next part, x factorial, takes out the repeats. Right. This is the official formula. And we can do this. This works out pretty easily. Because if I have 10 combinations 5, I've got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then this is divided by 5 factorial, which is 10 minus 5, right? And that takes, this is 5 times 4 times 3 times 2 times 1. That takes out that. And because I have x is equal to 5, I have another 5 factorial. So this one takes out those. Then I've got 5 times 4 times 3 times 2 times 1. And I can go into this with the 5 times 4 times 3 times 1 and cancel things out of here. So if I want 10 things taken 5 at a time, order doesn't matter. Combinations, what do you suppose the Excel command for combinations is? Start to type COM. You get combinations. COMBIN. 10 things taken 5 at a time, and you get 252. That's a combination. Permutations and combinations. In permutations, order matters. In combinations, order doesn't matter. It's a permutation with the combinations removed, the order removed. All of this gets us to the binomial distribution. This is the only one we've got that is really discrete. Everything else is normal distribution, which can be any value, any fraction, any small part. Binomial is this or that. And this is used a lot in quality control. So it is a probability of success or failure. And a success may not be what you think of as a success. It can be contracting Ebola. It can be having a defect, right? The probability of success in the binomial is a P. Just write P for probability. And it's the probability that something is a success. So this is the binomial, and it is written n things taken x at a time. If I wanted one defect out of 10, this would be 10, that would be 1. This is the probability of success. 1 minus the probability of success raised to the n minus x power. So this is the part we need. This is combinations. This is how many ways can this happen? How many ways out of 10 can I have one bad? It could be the first one, second one, third one, all the way up to 10. This gives me that, and this is the probability of that occurring.